complex queries. H.1 correlated nested queries. Last time I talked about nested query, the definition of nested queries. But here, another variation of this correlate of the nested queries, correlated. Yeah, because when you look at the nested queries, sometimes it may not be correlated. Sometimes it is correlated. Oh, sorry. Sorry, I forgot to dismiss the screen. Turn it off. All right. Yeah. So first, let us look at the definition. All right. Definition: whenever a condition in the where clause of a nested query references some attribute of a relation declared in the outer query. Look at this long sentence, outer query, because we have outer query, inner query. Here, outer query, yeah, we know the outer query, right? Select from our typical, where, yeah, this is the outer part, right? Yeah, outer part. Then inner part, right? Inner part, then there is some special condition we need to consider. Yeah, what's that special condition? All right. All right. Some attribute, yeah, where clause, right? A nested query references some attribute here. We talk about some attribute here, right? Yeah. Okay. Some attribute here. Yeah. It is referenced in the inner query. Yeah. Yeah. Declared in the outer query. Yeah. So that's the outer part. Referenced in the inner query. And the two queries are said to be correlated. Yes. That's the definition. Yeah. Because in some of the cases, in the inner query, we may not refer to any attribute in the outer query, right? Sometimes we have that kind of situation. Yeah. But we also need to consider the situation in the inner query. We may need to reference some of the attributes in the outer query. Yeah, that's quite common. Yeah. So we need to consider this type. Yeah. All right. Understanding correlated queries. Yeah. When we have this situation, in which way we should understand it. Yeah. Here, this is the way we understand it. We can understand a correlated query better by considering that the nested query is evaluated once for each tuple or combination of tuples, yeah, in the outer query. Yeah. So here, yeah. Outer query, yeah. So each tuple, yeah. So each tuple here, outer query, we can imagine there are a list of tuples, right? A list of tuples. Yeah. So let us imagine the outer query in general, it should return a list of tuples. Okay. Yeah. Here we can consider it as a loop. Because when we have list of tuples, we need to loop it, you know, one by one, go through all the tuples through a loop variable, tuple variable. Yeah. Sometimes we may imagine there is some tuple variable we use, you know, for you know, each tuple, each one as representative. Yeah. But when you consider each, before you get into the inner loop, you just fix it. How about that? Fix it. Yeah. When you get into the inner query, yeah, you fix that tuple. Okay, just right now, let us just consider that current tuple. We fix that current tuple, then we get into the inner query, and when we work on the inner query, we assume that outer tuple query of the outer tuple, outer query, we fix it. Yeah. Because we fix that tuple, now other things can be changed. Yeah. We fix it, for example, for employee. That employee with that SSM, that employee is fixed when we evaluate inner query statement. Yeah. So that is the way. So let me read the sentence again, this long sentence that we try to understand. Yeah. We can understand a correlated query better by considering that the nested query is evaluated once for each tuple in the outer query. Yeah. So we start from outer query. Yeah. Outer query, before we look at the inner query, the outer query should generate a list of tuples. Okay. Yeah. The details, yeah, we do not count, yeah, because details we need to work with the inner query to finalize all the details. Yeah. Before we get into the inner query, let's take each tuple in the outer query. All right. Take once. Yeah. Why once? Once. When you work on that, you fix it. Yeah. So when you move into the inner query, you fix that current tuple in the outer query. So then you can move into the inner query and do the usual query processing. Because this time it's a single query, right? Yeah. Single query. The outer query already fixed. That result already fixed. Yeah. So you take that result, then you get into the inner query to do the query processing. Yeah. Use this kind of understanding. Yeah. We try to understand the whole nested query statement. Yeah. All right. And any and some. Yeah. Later we will see many examples. Yeah. Here. Yeah. Let's look at this. Any and some in combined operations. Yeah. That keywords, yeah, equals any or equals some operator. Equal any. Yeah. You can guess the meaning. Equal some. Okay. Equal any. Yeah. Its meaning. Equivalent to in. Yeah. We already used that in operator last time. Yeah. Equal any. That's the same thing as in, right? Yeah. Yeah. And in, actually, we feel more comfortable use that in operator, right? Yeah. But some people, sometimes they use that equal any. So you know, the same thing. Yeah. Yeah. Equal some, yeah. Some, yeah. A different way to write that equal any. Yeah. So this kind of thing. Yeah. Other operators other than equal that can be combined with any or some. Yeah. Yeah. you can see these operators. Yeah, this is just, dash. So that's not the symbol. After that dash, all right, greater than, greater or equal, less than equal, and not equal. Yeah, this is not equal. Okay, yeah, not equal. All right, yeah. And you can understand from the meaning easily. Yeah. All right. One example here, you can see the maximum. Another way we represent maximum, salary greater than all inner query, right? So this is inner query. Okay? Yeah. Salary of the employees in department 5. Okay. Yeah, that greater than all. Okay. Or you can imagine that's the same as that greater than the maximum salary in department 5, right? No. So you can write it in a different way, the maximum. Yeah. All right. Yeah. So that's the example. Yeah. But here you can see this nested query. This is not correlated, right? Yeah. Because in the inner table, we do not refer any attribute in the outer query, right? Yeah. So here you can see this one is not a nested query. Sorry, not a correlated nested query. That would be easier. Yeah. Usually, a nested query, if it is not correlated, nested query will be easier. Yeah. Because the outer inner independent, you can work outer query, inner query independently, right? No correlation. When you have a correlation, then you have to work outer query, inner query together. Yeah, dependent, yes, in a dependent way. Yeah. So that's the main difference. So correlated type will be relatively harder. Yeah. Next topic, H.2, aggregate functions. Yeah. We did a little bit, but I haven't discussed, more cases. Yeah. Yeah. Aggregate functions, yeah, summarize information from multiple tuples into a single tuple summary. Yeah. By aggregate function, several aggregate function, single tuple summary. Okay. After you apply the aggregate functions, yeah, look at these aggregate functions. Count. Yeah, we use count several times. Yeah. Sum. Yeah. Another one. Max, min, average. Typically, we use these aggregate functions frequently. Yeah. All right. In order to use aggregate functions, another concept usually associated with some of the aggregate functions, grouping concept. Grouping concept. Yeah. When I did grading on your homework assignment number 2, some of the students already use this grouping concept, the grouping way. Yeah. Yeah. It's very convenient, very useful. Yeah. But here I like to, explain it completely. Yeah. So later, so we will try to use this grouping concept as much as we can. Okay. All right. Grouping is used to create subgroups. Yeah. Subgroups. Yeah. So here you can see, when you see the keyword grouping, then you need to split the whole list of tuples in multiple subgroups. based on the, the criteria in the grouping clause of the tuples before summarization. Before you apply the aggregate functions, you need to define groups first. Okay, the grouping clause tells you how to define the groups, subgroups. Then you can apply the aggregate functions on each subgroup. Okay, all right. But if you do not define subgroups, then that means the aggregate functions will be applied on the whole group. We treat as one group. The whole list of tuples we treat as one group if you do not use that grouping keyword to define subgroups. All right. Use group by clause. Grouping is the concept. Grouping is the concept. But when you write a statement, you use the group by clause. You do not use grouping keyword. That's the concept. In our discussion, we use this grouping concept. All right. Example, a correlated nested query with an aggregate function. Let's look at this question. Retrieve the names of all employees who have 2 or more dependents. We did a similar question, right? I remember similar question, but because we have many different ways. All right, so here, let's look at the old way. Select first name, last name from employee as E. That's the outer query. Then we fix that one individual, one employee, current employee. Then we fix it. Okay. Then we bring that fixed employee into the inner query. Not a unique. So here we use the unique function. Unique. Select star from dependent where E.SSN equals ESSM. So the return result not a unique. Unique, that's one, right? One tuple, that's unique. Single tuple. Not a unique, more than one tuple. Not a unique. So here you can see the inner query, we need to refer to the E, actually tuple, all right? Current tuple, E.SSM from the outer query. Okay, so you can imagine this E.SSN, this fixed. When you work on the inner query, you fix this E.SSN. So you go through all the tuples in the dependent table, looking at the ESSM. When you do comparison, you fix that E.SSM from the outer table. That's the way you understand this correlated nested query. All right, But one thing we should be careful, because this unique function not available in MySQL. All right. So that means we try to avoid it. In other DBA method, it may work, but MySQL does not support it. Or probably for certain version. I didn't check. So when I taught before, it does not support. I didn't check recent versions. So that possibility. And the new version, so we can get around it. If it is not supported, if this function, unique function, is not supported, then we need to get around it. We can use the count function. Yep, not a unique count the number of dependents for that fixed employee greater or equal to 2, right? Yeah. So the second way we write this one. Yeah. Here, the inner query, yeah, aggregate function count, and you can imagine when you work on the condition, you fix the SSM, the tuple in the outer query. When you bring it into the inner query, you fix that. Yeah. So then when you change ESSM, yeah. So you can see, yeah, when you go through all the ESSM, there is only one ESN that matches the outer SSN. Okay, yeah, so then you will have the result. Yeah. All right. Next, max and the min functions. Yeah. We use that, right, in our B date, the birthday, yeah, the minimum of the birthday. Yeah, we use that. Yeah. All right. So here, let us look at the general case, max and the min, general. Function usage. Yeah. All right. Can we apply to a set or multi-set of, can be, yeah. So here it's not a question. Yeah. Can be applied to a set or multi-set of numeric values. Now, the first way, numeric values, yeah, you can compare maximum, minimum, well defined. So no problem, you can do that. Yeah. But the second case can also be used with attributes that have non-numeric domains if the domain values have a total ordering among one another. Yeah, I explained the total ordering concept before, right? The total ordering concept. Yeah, every 2 elements in that domain, you can do comparison. Greater, equal, less, you can do that kind of comparison. That's the total ordering. And we have another ordering, partial ordering, right? Yeah, it's different from total ordering, partial ordering. Yeah. All right. Total ordering and a partial ordering. Yeah. Total ordering, every 2 elements. Yeah. So here I explain the meaning again. Total ordering, every 2 elements can be compared in one of the 3 cases. But partial ordering, if A greater than B, B greater than C, then A greater than C. The transitivity property is available. Yeah. But it is not necessary that any 2 elements can be compared. You may have a situation where you pick 2 elements, then none of the 3 cases would be true. They're not equal. The first one is not less than the second one, and the first one is not greater than the second one. None of the 3 cases is true. For the partial ordering, you may have that situation. Okay, yeah, that's the partial ordering. But here you can see max and min can only be applied to total ordering, not partial ordering. For partial ordering domains, you cannot apply max and min. So it's special. It's special from that count function, right? Count function, even for partial ordering, we can apply a count function, right? We just count the number. So we don't need to worry about that ordering thing, right? Even though ordering, we can counted, right? Yeah. But max and the min, the condition is stricter. Yeah. You have to have a total ordering. Yeah. Okay. All right. H.3 partition for grouping. Yeah. Now, in order to understand that grouping concept better, we need to use the partition concept to help us understand it. Yeah. All right. So what's the partition? Yeah. Partition concept for grouping. Yeah. Because we need to define subgroups. When we define some subgroups, basically, we just do a partition operation on the list of tuples. What's that partition? Yeah. Yeah. This partition concept we learn in discrete math. Yeah. So if you still you remember what you learned, yeah, in discrete math, there is a partition concept. Here, let's review a little bit. So what's the meaning of this partition concept? You know, from math, partition of a set. Given a set, we can do a partition on a set. Yeah. Here we can extend it to partition of a multiset. Okay, multiset, set, multiset. All right. In math, partition a set into subsets. We need to have the following conditions. Okay. First condition, covering the whole set. Yeah. Then we can call it a partition. Now, all those subgroups, if you put together, you do not miss any element in the set. You cover all the elements in the set. So the first condition, the whole coverage condition, covering the whole set. Yeah. All right. Yeah. The union. Yeah. So here just explain that meaning. The union of the subsets equals the whole set. Yeah. So that's the first condition. The second condition, non-overlapping condition. Two subsets cannot have any overlap. Yeah. So the intersection of any two sets is empty. Yeah. So that's the requirement for different subgroups. Yeah. Otherwise, when you apply aggregate functions, you may count more than necessary, right? Yeah. So that would be wrong. Yeah. So you have to have the second condition, no non-overlapping condition. Okay. The third condition, non-empty condition. Yeah. None of the subset is empty. None of the subset is allowed to be empty. Yeah. This requirement also natural, because if you have an empty subset as part of the partition, you can remove it, right? Why need that empty subset in your partition? You can remove it from the partition to simplify your partition. Now, so with this concept, then you have a valid partition. Yeah. After you understand this partition concept well, when we do grouping, when we define subgroups, so you will get an idea. Yeah. So the right way to define subgroups. Okay. All right. Yeah. Yeah. Here we just, in the math subsets, we treat as groups or subgroups. Yeah. All right. Groups and grouping attributes. Yeah. Partition the relation into non-overlapping groups of tuples. All right. How to partition the relation? Yeah. All right. Each group will consist of the tuples that have the same values of some attribute or attributes. Yeah. Sometimes you can use multiple attributes, not necessarily single attribute. Okay? Yeah. Multiple attributes, you can define a tuple value, right? When you use multiple attributes, basically you have a tuple value. Yeah. So you can consider value in the tuple format. All right. Yeah. Called the grouping attributes. Yeah. Yeah. So here you can see each group. Yeah. Or each group. Yeah. Each group we know there are. So here, each group or subgroup, sometimes you can call subgroup, okay? You have multiple tuples, right? Yes, certain number of tuples. And these tuples, they share the same attribute value, or sometimes attribute tuple, because we have multiple attributes, so we form a tuple. Attribute in tuple format, that value, same value. How about that? Okay. For example, here, let me give you an example. Suppose we have attribute 1, attribute 2. Okay. This form a tuple. Okay. Yeah. But attribute 1 equals V1, value 1, V1. Attribute 2 equals V2. Yeah. So the tuples in this group should have the same value in this V1, V2 pairs. All right. For example, 1, 3. All right. All the tuples for these two attributes should have the 1, 3 value, 2, 4 value, and so on. All right. Yeah. 1, 3 value and 2, 4 value, you cannot put them in the same group. Yeah. In the same group, those elements, they should have all the 1, 3 value. Something like that. Okay. Yeah. So called the grouping attributes. Yeah. Example. Yeah. All right. The first example, select department number, and we need to apply the count function on each group. Yeah. So here, each group. Yeah. When we apply aggregate on each group, average of salary, we apply on each group. Now we want to see how do we define the groups. All right. Yeah. From employee, group by department number. All right. Department number value, we know 1, 2, 3, right? 1, 2, 3. Okay. 5, 6. All right. Each department number, the employees with the same department number, we put them in the same group. Then we apply count function, average function, we apply on the whole department. That makes sense, right? Yeah. Pretty straightforward, this understanding. Yeah. All right. Null value in the grouping attribute. Yeah. We may encounter null, right? And we know null values are treated as different values. Yeah. So when we consider null values now, we need to be careful. Yeah. If nulls exist in the grouping attribute, then a separate group is created. Yes. Because Look at that. If we do not treat in the special way, then it won't be convenient. Yeah. Here, we treat in this way. A separate group is created for all tuples with null value. And we put them in one group. Yeah. So, because each null value we treat as different value, but we don't want to make each null value as one group, right? One single group. That won't be good. Yeah. Too many groups, right? Won't be good. Yeah. So we like to put all the tuples for that grouping attribute. Yeah. Here we consider grouping attribute. Their grouping attribute, when they take the null value, we put them in one separate group. Yeah. Example. How many employees are supervised by each supervisor? Yeah. So when we do the counting on this one, count function, we know there are some employees who do not have the supervisors, right? Yeah. Those top level people. There are several top level people, they do not have supervisors. So their supervisors take the null value. So we should put them in one single group. Yeah. And all right, we count. Count parenthesis SSN from employee group by super underscore SSN. Super underscore SSN could take the null value. All those employees with null value for super underscore SSN, we put them in one single group. So then we apply the count function on that single group, null value group. Yeah. All right. So you can see when we do the counting, this is the count result. Yeah. So here, in order to show explain result, and the first one, 7, that corresponds to the null case. Null case, that number equals 7. There are 7 employees who do not have the supervisors, okay, in a single group. Yeah. All the remaining groups, yeah, so 3, 2, yeah, so yeah, so that's the, you know, not a null value. Yeah. All right. So that's this example. Yeah. All right. Another example, a join condition in conjunction with group by. Yeah. Group by join condition. Yeah. In conjunction. Yeah. You look at this question. For each project, retrieve the project number, the project name, and the number of employees who work on that project. Here, project number, project name, yeah, and the number of employees, that number, count, right? Count. So we need to consider the group definition, yeah, on that project, work on that project. So you know how to define a group, right? Yeah. Based on the project. Yeah. Work on each project. So you can define a group. Yeah. On different projects, so you define different groups. Yeah. Yeah, but here the question, yes. Think about, yeah. Let's look at the answer first. After that, we do some further discussion. Yeah. All right. Select P number, comma, P name, comma, count parenthesis star, okay, from project table, works on table, where join condition P number equals P0 for two different tables. Let us define the group. Group by P number and P name, comma. So here we use two attributes to define a group. So the question, why we use two attributes? Can we use one attribute? Why we use two attributes? Right? Yeah. In this case, the grouping and the functions are applied after the joining of the two relations. Yeah. So we join two relations first before we apply grouping condition. We join two tables first. Yeah. So we have one result table. You can imagine after the join operation, we have one result table. Then in that result table, we define groups based on project name, project number to define. Okay, yeah, all right. Here the question, project name, project number, we know each project has one project number and one project name, right? One-to-one correspondence. Project number is the ID of a project, unique value. Project name also unique, right? How can you make two different projects the same name? You cannot, right? Project name also unique, unique project number, unique project name. But if you use two attributes, that's the same as using one attribute to define a group, right? Yeah. Because project number is already enough to define a project group. The couples with the same project number in the same group. Okay, all right, yeah. So this part, this group definition, we can simplify a little more. Yeah, the same as we just use one attribute to define the groups. The second one is redundant, not necessary. Yeah, actually, it would make more confusing, right? When you try to understand, try to think about the two attributes group definition. Yeah, so it would be harder to understand, right? Yeah, so that's one thing. But another thing is, all right, okay, oh yeah, so here, count the number of employees, yeah, works on, yeah, all right, yeah, yeah. Here, think about, yeah, the reason I like you to think about a little bit is, we know one employee could work on multiple projects, right? One employee could be working for more than one project. That's true. If we look at our data, that's the case. Yeah. And usually, many employees, they participate in multiple projects. Yeah. All right, yeah. But with that assumption, with that situation, when we define groups, do you think our group definition looks fine? Yeah. Yeah, actually, it's all right. Yeah, it's all right. Yeah. Yeah, even one employee can work on multiple projects. Yeah. When we do the counting, because we count with respect to individual groups, each group, we just want to count the number of employees working on this project. We just want that number. Okay, yeah. For two different projects, if one employee is counted twice, no problem. No problem. No contradiction. Yeah. That's the truth. That's the real case. So we don't worry about that. No violation, no contradiction, no violation. Okay, yeah. All right. Let me look at the time I have. Yeah, still 10 something. Yeah. Oh, I forgot to change the title. Yeah, so because we already, yeah, the title should be different. The title should be inner join, outer join. Yeah. All right, let me go back to, yeah, I forgot to change the, inner join and outer join concept. All right, yeah. I already saw a few students using the inner join, outer join concept in homework assignment, homework number 2. Yeah, some students already use that. Yeah, but here I like to explain the meaning. Yeah, so when you use them, use in the right way. Okay, yeah. All right, so inner join. Yeah, inner join, we're familiar with it because the inner join is the default join case. Okay, yeah, the default type of join. If it's default, you don't need to specify it, right? Yeah, so if you write inner join, you can remove that inner join keyword because that's the default, right? That's why we put two tables side by side, separate by comma, that's the inner join, all right? Because we do not write that keyword. So we use the default case, inner join, all right? Yep. All right, condition. But if you use inner join, you need to be aware of this condition. Okay, aware of this condition. Yeah. A tuple is included in the result only if a matching tuple exists in the other relation. What do you mean exists? Matching tuple. Not a null value. Yeah. The matching tuple, yeah, because you write join condition. Yeah. Attribute 1, yeah, let's say attribute 1 equals attribute 2. All right, yeah. Attribute 1 equals attribute 2. All right. Attribute 2, if attribute 2 happens to be null value, you should not select it, right? Yeah, because it does not exist. Yeah. If attribute 2 null, then not selected. Because for inner join, we do not allow this to happen, right? Inner join, when you apply the join condition, we do not allow that null value involved to be selected. All right, yeah, that's simple. That's the default meaning of that inner join. Yeah. All right. But in the real world business, people sometimes they need to include the null value. When they join two tables, when they apply the join condition on two tables, they like to include the tuples with null values for the attribute join attributes. They like to include. In that case, we need to use the outer join concept. When you need to include the null values in the join condition to be selected, make the tuple to be selected, you need to explicitly use the outer join keyword. Yeah. It's not default, so you need to explicitly write it. Yeah. Specify it explicitly, not default. You have to write outer join. Yeah. But when you write outer join, there are two cases to be considered: left outer join and the right outer join. Yeah. So here, let me describe these two outer join types. Yeah. Require that all the tuples in one table included, even if no matching tuple, that means the null value thing. All right, no matching tuple in the other table exists. Okay, in the other table, no matching tuple, no. Null value, you still include it. Okay, but you, because there are two tables, yeah, you want to make tuples in one of the two tables all selected. Think about this requirement. Tuples in one of the two tables must be selected. That's what you want to do, want to have. Okay? Tuples in one of the two tables must be selected. Either left table to be selected, all tuples in left table to be selected, or all tuples in the right table to be selected. These two cases. Yeah. Outer join, these two cases. Yeah. So you have left outer join and right outer join. You have to specify. You want to do left outer join or right outer join. Hey, yeah. All right. Yeah. So the null case. So left outer join, right outer join. Now you can, from the name we call it, the join types, you can immediately understand which table whose tuples should all be selected. Right? Left outer join, all the tuples of the left table should be all selected, and so on. Vice versa for the right case. All right? Yeah. Left outer join, all tuples in the left table included. Yeah. Some of them you may have the join condition equals null value for the right table attribute. Null value, that's fine. Null value, okay, still selected. Yeah. Right outer join, all tuples in the right table included. Yeah. Join condition, left table attribute, corresponding attribute could be null value. Yeah. Must be selected for the right table. Yeah. All right. So yeah. So you can see sometimes we like to get that information, right? In the real world. So whatever you have, yeah, we want to have information in this way. So left outer join, right outer join, and the inner join. So you know the difference when you join two tables. Okay. Implicit join, explicit join. We talked about that before, right? The concept. Last time I also talked about natural join, right? That's another different way to join two tables, natural join. Yeah. Slightly different. Although natural join is rarely used, but the concept is there. Yeah. All right. Let me see how much time do I have. Yeah. Just less than 10 minutes. Yeah. We can complete this part quickly. Yeah. All right. Example. Using outer join. So let us see a few simple examples here. Yeah. Question. For each employee, retrieve the employee's last name and the last name of his or her immediate supervisor. Yeah, let's look at this condition. Right. Immediate, yeah, immediate supervisor, yeah. Because we know supervisor may have another supervisor, right? Supervisor is supervisor. Yeah, but immediate supervisor, just that supervisor, all right? Where an employee tuple whose value for super underscore SSN is null is also included. Yeah. Here, if some employee has no supervisor, that means super underscore SN is null. We want to include, we still want to know that information. We don't want to remove that information from the query result. So in this case, we need to use the outer join. Yeah. All right. But this time, the outer join, both tables are employee tables. Employee as E left outer join. That means the left employee table, all the tuples should be there, should be in the query result. Yeah. Then the supervisor copy right table. Yeah. So then, yeah, not necessarily included. Yeah. Right. Yeah. But because here the same table, two different copies of the same table. Yeah. On, so we specify the join condition on. Yeah. So that condition. Yeah. Okay. Yeah. So you can see after we learned the concepts today, now you can understand the statement. Yeah. So nested query statement. Yeah. And outer join. Yeah. All right. Yeah. Next, yeah, let me see. Yeah. So I finished my plan today. I have a few minutes, so let me talk about in the project part what I plan to do. I plan to create 2 more sample examples. So we already have, yeah, let's say we already have sample 1 example. Okay. Yeah. So that input data, yeah, enter new data. Oh, yeah. Yeah, I need to convert to MySQL version. Yeah. So when I go back tonight, I will make that conversion. Then I will post version 2. Version 2 under the same name. So that's the MySQL version. Yeah. The current version is MySQL version. Yeah. But for some students, they cannot run MySQL version directly. So they need to run a newer version, MySQL version. Yeah. Then after that, I plan to create sample 2 because we need to edit, right? We need to do edit row feature, right? Row edit feature. But when we do row edit feature, in our 5 tables, we have 3 tables with primary keys and 2 tables without primary keys. Okay, yeah. Here, when we do editing, so we need to use different ways. Right. Primary key, we just use the primary key to identify. Okay, different ways. Yeah. That's simple. Yeah, the first case, relatively simple. Okay, yeah, just using primary keys. Okay, all right. But the second way, we need to identify rows, right? Identify rows. And the last time I mentioned there is one way using certain certain fields, certain field values. Yeah. Those two tables, yeah, we can use, definitely more than one. If you use one, you can identify that that's the primary key, right? That's the key, right? So more than one. Yeah. When we use two values or three values to identify, yeah, that's possible. Yeah. When I look at the data, yeah, we can use two or three field values to identify. Yeah. So then when we implement that feature, we need to do in these two different ways. But there is some techniques, JavaScript function, change the user interface. So then submit the form and call the backend PHP function, backend PHP file to do data processing. Yeah. Here, I try to help those students without much web programming experience. Some students with quite some web programming experience, so you're fine. Yeah. You just use your way to solve the problem. That's what I like to see. Okay, that's what I like to see. But I like to help those students with very little web programming experience. Yeah. Some students with very little. Yeah. So this project probably relatively hard for them. So I like to provide another sample example for them. Yeah. So that's the edit, but when edit, the same time update should be together with this one, update. All right. Yeah. And another case, sample 3, delete, right? Yeah. Delete, but after we complete sample 2, then it should be easier, right? Yeah. Because delete, we can identify, right? Yeah. We can identify primary key, use the values, key values, yeah. Yeah. Actually, the hardest part is the sample 2. The sample 2, yeah. With sample 2, probably you do not need me to give you sample 3, yeah, because you can do the deletion using the same way we use in sample 2. Just change your query statement a little bit from update to deletion. How about that? Update to deletion. Yeah. So that will be very simple. Okay. All right. Yeah. So I run out of time. So let me stop right here. Yeah.